classes that you typically take if you're going to be a science major. And then do a couple of examples of topics that we talk about at some point during the year in Math 115, 116. So I don't know how much math any of you have done. So you've all done Algebra 2 and trigonometry and pre-calculus and maybe some calculus? Some? You loved it? You have mixed feelings? Okay. Well, nice thing about university, college is you get a chance to start over. Math is a subject that everybody's got an opinion about. Right? It's one of those things, because we've all been exposed to it from the time we started school. But what we do in university is a little bit different. And I'm just going to go through the beginnings of a document that you should have access to. I think I sent it to you, and
yes,
this is a whole bunch of information, far more than you need, about the options that you have and the kinds of decisions that you might make in the fall when you register. So there are basically two flavors of mathematics that you use in science classes: calculus and probability and statistics. So both are important as far as tools in the sciences. It could be that probability and statistics is in fact a bit more important. It's the kind of thing that you use much more frequently in areas outside of your classes. The standard calculus sequence for people who come in without AP credit is Math 111, 112, Calc 1 and Calc 2. Don't presume any calculus, just presume a strong pre-calculus background. They serve students who want to learn economics and physics, some chemistry, or math. Math 115, 116 is different in that it's designed specifically for biology majors. It's required by the BS in the BS program in biology. It's recommended by NBB, neurobiology. It starts off the same as a standard calculus class in Calc 1, but then we move a little bit away from typical sort of physics examples and do more with life science modeling, exponential growth and decay, that sort of in the fall semester. And the spring semester is really a lot different than calculus 2. It's quite a bit of applications of differentiation and integration, tools from calculus, modeling, and biology. For the first half, and the second half is probability and statistics. So it's a different kind of calculus class. As long as you've got a good pre-calculus background, you're prepared for either option A or option B. The other courses are higher level math courses that are typically taken by not so many freshmen. Only if you've maybe done BC calculus in high school would you do that. Then there's another set of courses that have to do with statistics. One that's new here last year called QTM 100. This is an introduction to stats. Right now it's required by social science majors, and biology is thinking about requiring it depending upon how the course develops in the near future. But for entering students this fall, the Math 115, 116 is the typical math requirement for the bio major. How many of you are thinking of a bio major? And the rest, NBB, maybe non-committed, undecided? But everybody in the program has an inclination toward doing some kind of science. You can interrupt me, honest. Ask questions. Otherwise, this will go really, really quickly. So this document's got a lot of pages in it, and I said more than you'll need to know, certainly. But I just put it in to give a flavor of what math course is like in college. First of all, placement. What sequence do you want to take depending on your interests and your background? The second thing is a 5 or 6 page information handout that I give out at the beginning of Math 115. just how you're evaluated, expectations, that sort of thing. So one thing that might be different about how a class is delivered here versus high school is the professor will create a document like this for you, like number 2, which is, and so lots of straightforward information. But once we give this to you, post it on Blackboard, the tool that's used for keeping track of courses and posting assignments and that kind of thing, then we feel as though we fulfilled our responsibility for explaining what's expected of you. So the upshot is you need to read this stuff and pay attention to it. And then the following will not happen. The day of the first midterm, someone will come into class, sit down and say, "What? I had no idea." Everything's in here. Schedule for the class. Of course, I constantly remind you when assignments are due or when exams are coming up and so on. Believe it or not, not everybody comes to class all the time. Okay, maybe I shouldn't have told you that. And so you really are responsible for keeping up with things. All the information's there. You only sort of have yourself to blame if you don't keep track and stay current. So again, this is it may be a difference between university or college and a high school class is that we post this stuff, we talk about it, and then we expect you to have access to it and pay attention to it. Another thing that you'll notice, and you'll notice this with math classes, you'll notice it with language classes, is things tend to move quickly. You have maybe only 2 meetings a week in a class, maybe 3, and yet you'll be zooming through these chapters. It's a pace that's quite a bit different than the high school pace. And the expectation is that you're doing a lot of work outside of class, keeping up, and so on. Also, you're just taking 4 classes, typically plus maybe a health or a PE. And so you really are expected to concentrate on those classes and to keep up with them. To add to that, math, like language, is really vertically organized. So what you do on day 1, you don't get to forget it on day 11. Everything is built upon what happened before. So if you're scratching your head wondering, whoa, this does not make any sense, it could be because there's something in the first week that wasn't properly digested. So here, we stand up at the front of the class at the beginning and we urge you to come and see us if you fall behind, if you have any questions about the lectures, if you just want to talk about the material in the class. So talk to us, the teachers, there are TAs, there are graders, all kinds of resources. There are also various kinds of tutoring programs available through the college, depending upon the subject and the class itself. So you should be able to take advantage of all these things if you need to.
Question?
Yeah.
Do all the math courses and everything come with lab components or only some?
No, there's only a few that do right now. 115, 116 has an extra hour a week of lab. And let's see, 221, the linear algebra class has one. But those are the only 2 at this time. So one thing is that starting this fall, that means those 2 classes carry 4 credits rather than 3 credits. The way we use the lab in 115 and in 116 is mostly for extra practice, opportunities to ask questions about stuff that's been covered in lectures, maybe some group work. Also, we do quizzing in the labs. There are frequent quizzes. You're supposed to, it's a fairly well accepted tenet of education now that frequent testing leads to more retention. Well, it leads to more anxiety too, but more work for everybody involved. So I was gonna tell, yes.
So if I do badly on a quiz, should I just keep that to myself and go back to my room and get mad at you because you didn't teach me well? Or what would you recommend I do if, under the weird circumstances, that I don't do well on a quiz?
This is a leading question.
It is.
There's only one right answer to this question. For one thing, there are lots of quizzes, and usually we drop low scores. 1 or 2 during the semester if we have, say, 10 quizzes. But the reaction to booting a quiz is to sit down with it and the solution set, the key, and first figure out where you stopped understanding, where the mistakes occurred, and then to come to see me or to see the lab instructor and to go over it. One thing that some students seem to like is getting a study group together, because you learn something best by explaining it to someone else. So if you're in a group with someone else and you're talking about a new topic, then being able to see what's causing other people problems helps you understand what causes you problems. And having to explain to someone for the 14th time why a limit is a limit, you really begin to understand why it is what it is. So, besides encouraging you to see your teachers, I also encourage you to form study groups and to work together with a group of peers. I know this happens very frequently in a lot of the lab science classes. And lab science classes lend themselves to this because there's so much contact. There's long labs, wet labs, as well as lectures. So, it's a solution that's good for math too. Okay. So now for the content portion. If there are any organizational questions, I'll be happy to stay after and talk to you about anything that occurs to you. Yeah, this is 2:30 to 5 on the schedule?
Yeah.
We're not.
No, it's as long as you need it to be.
So,
They were all excited. They were like, math until 5 o'clock. I love it.
hallelujah. So a few years ago, maybe the first time I taught, so the classes are either 3 50-minute meetings, or almost all of them now are going to be 2 75-minute meetings a week. 75 minutes is a long time to stay attentive. I won't say especially in a math class. But I remember an evaluation from the first semester I taught 75-minute classes. And the kids said, there was a pretty good class, but God, I couldn't stay awake for the entire 75 minutes. So, we do our best to be entertaining. But usually with a 75-minute class, we'll break it up. At some point in the middle of the